The next topic is radical expressions. The first thing we're going to review is how to write things using exponents. They usually put these kind of questions on the SOL. So for the first example, it will say in the directions, how do you write this in exponents, or something like that. And so what you would do is you would take whatever's on the inside, so we have x and y, and you raise them both to a fraction exponent. So what you do is you always put whatever the index is, that's the small number outside, on the bottom. Then you put whatever the exponent is, so like 2 in this case, and in this case y doesn't have anything, so just 1 on the top. That's it. If you can simplify, then great. If not, you're done. So for the next one, same thing. I have 3 to a fraction and x to a fraction. Both of them are under a square root, so I put 2 on the bottom. And then the exponent of both of these is just plain old 1, so put 1 on the top. Last one, we have x and y. They have 6 on the outside. And then x has a 2 on top, and y has a 3. So this is a case where now you can simplify. 2 over 6 reduces to 1/3. And 3 over 6 reduces to 1/2. That is your final answer. And they may include the unsimplified version just to be meanies, so make sure that you are picking the simplified version. The next topic is simplifying. So it says use a factor tree to simplify. So that means I have to break down 180, so 2 and 90 go into it. 2, it's done, it's prime. So I circle it so that I know that it's prime, because sometimes some of you get confused about what's left over and all that. So circle it if you cannot go any further with it. 90, 2 goes into it, and 45. Now for 45, 2 doesn't go into that. So if 2 doesn't go into it, then try 3. If 3 doesn't, then try 5 and 7. Those are all the prime numbers. If 3 goes into it 15 times. 15, 2 doesn't go into it, but 3 does. 5 times. So then what I do is I circle the doubles, since this is a square root. So it has a double 2 here and a double 3. I disregard all the things that aren't primes, so all the things that are not circled. So then what I do is I have my 4 that's originally out there, but then I bring out my doubles. So I have a double 2 and I have a double 3. I only bring 1 out for each double. You also have to remember your x's and your y's. So if you can just look at 5 x's and figure out how many doubles, then great. If not, you need to write out 5 x's and 7 y's, and then circle the doubles. So I have 2 double x's and 3 double y's. Now for underneath the radical, I have that 5 left over right there. I have an x left over and a y left over. So now I'm just going to clean it up. So on the outside, I'm actually going to do 4 times 2 times 3, and that gets me 24. X squared, y cubed, and 5xy. Next topic is multiplying. So for multiplying, you just multiply the insides times the insides and outsides times the outsides, and then you simplify with the factor tree. So for the first one, I multiplied the 2 outsides together. That gets me 8. And then I multiplied the 2 insides together, and we're going to talk about the trick later with that when they're the same. So that gets me 25. Then I break down 25. 25 is not divisible by 2 or 3, but it is divisible by 5. It's 5 and 5. So that's my double right there. So then I take that 5 on the outside and I multiply by the 8. And I get 40. There is nothing left over underneath the radical, so 40 is my answer. Next example, when they are binomials, so if you see an addition or subtraction sign, that means you need to use the box method or FOIL. I'm just going to show you the box method because if you know how to use FOIL, then go ahead and use it. So for the box, I put the first parenthesis up top. So 3 plus radical 7. And then I do 2, put the minus in front of the radical 7. Then I multiply to get what's inside the box. So the first box, 3 times 2 is 6. The second box, 2 times radical 7 is 2 radical 7. The next box, 3 times negative radical 7 is negative 3 radical 7. And then this is where the trick comes in. So square root of 7 times square root of 7 is square root of 49. However, I taught you that if you have the same square root multiplied together, then it's just the number under the root without a radical. So square root of 7 times square root of 7 is just plain old 7. It is a negative, though, because it's a positive times a negative. Then, after you fill it in the box, you add the diagonals. So when I add the first diagonal, because they are like terms, it won't always happen, but in this case they are. 6 plus negative 7 is negative 1. Then I look at the other diagonal. They are also like terms because they have the same radical. 2 plus negative 3 on the outside gets me negative 1. And then I keep the inside exactly the same, 7. That is my final answer. The next topic is adding and subtracting. So when it comes to adding and subtracting, the radicals must be the same in order to add them, and you can only add the coefficients. So I'm going to break down 27 and 12 because they are not the same. So please do not just add the insides. That will make me very sad. So 27, 3 goes into it 9 times. Then 9, 3 goes into it 3 times. For 12, 2 goes into it 6 times. 2 goes into that 3 times. Now I'm going to circle my doubles. So on the outside of the first one, I have a double 3. On the inside, I just have that 3 right there left over. For the second one, I cannot forget the 5 that was originally out there. And now I have a double 2 that comes out. On the inside, I have this 3 right there inside. So just to clean it up a little bit, I have 3 radical 3 plus, I do 5 times 2, that's 10 radical 3. They have the same insides, so now I can add the 3 and the 10 and get 13, and I keep the inside exactly the same. That's my final answer. Next is dividing. So, for dividing, what I do is I cannot have a radical in the denominator. So if that is the case, then what I do is I rationalize. So to rationalize, I multiply by the same radical on the bottom to the top and the bottom. So in the top, since 4 is on the outside, it's going to remain on the outside, square root of 2. On the bottom, I said before that if you have the same radical multiplied together, that's a double, so it comes out of the radical. Last step, if you can clean it up, then do so. 4 and 2 are not under radicals, so I can divide them, and that gets me 2, and I still have that radical 2. The last topic is I. So remember, every fourth I is 1. So here is the pattern. It is I, 1, I, 1. The middle 2 are negative. This is something you will need to memorize. So every fourth is 1. So every multiple of 4 is going to be 1. Also remember that you can use the I button. How you do that is you press second and then the decimal place. So if I'm doing I to the 31st power, what I do is I ask myself, is it divisible by 4? 31 is not. So then I go one above it. I ask myself, is I 32 divisible by 4? Yes, it's nice and clean. 32 divided by 4 is a good number. So since that is divisible by 4, then that is 1. So then since that is 1, I go backwards, and so negative, or 31 would be negative I. The final example, what I have to do is you can certainly do the box method if you would like, but you can also just use your calculator. So I would just type it on in exactly how it's written. for minus 3i, so second decimal place, and then 2 plus I. Again, second decimal place. And that is what I get, and that is my answer. And that is it. So now you can go ahead and do the Socrative quiz.